Uniform circular motion. Before we start with the concept of uniform circular motion, let us see a small activity. Take a rotary lawn sprinkler having a vertical tube X to which 4 bent tubes A, B, C and D are attached. Connect it to a supply of water. Start the sprinkler on a dry floor and stop it just after completion of one rotation. What do you observe on the floor? Even though the sprinkler has 4 bent tubes and corners, how is the circular path followed by the sprinkled water? Let us find out more about this phenomenon. When an object is accelerating, its velocity changes. The change in velocity is due to change in its magnitude or direction of motion, or both. Suppose an object is moving with uniform speed on a square path on the straight line paths AB, BC, CD, DA. Then the object has to change its direction of motion 4 times. If the object is moving along a regular pentagonal path, PQRST, then it has to change direction 5 times to complete one round. For regular octagonal path, it has to change its direction 8 times. Thus, as the number of sides increase, the object has to turn more often. What would happen to the shape of the path as we go on increasing the number of sides indefinitely? The shape of the path approaches the shape of a circle and the length of each of the sides will decrease to a point. When the object moves with a velocity of constant magnitude along a circular path, the only change in the velocity is due to change in direction of motion. Hence, it is an accelerated motion. When an object moves in a circular path with uniform speed, its motion is uniform circular motion. Velocity can be determined as velocity is equal to circumference divided by time. Therefore, we have v is equal to 2 multiplied by pi multiplied by r divided by t. Let us see few examples. Motion of Earth around the Sun. Motion of the Moon around the Earth. Motion of the electron around the nucleus. Motion of a vehicle along a curved path. To determine the direction of uniform circular motion, let us see an activity. Take a rotating disc. Place a 5 rupee coin on it near the center. Allow the disc to rotate slowly and observe the coin. What happens to the coin? Now, allow the disc to rotate faster so that the coin gets thrown away. In which direction is the coin thrown off? Repeat the activity for different positions of the coin and note the direction every time. The coin moves along a straight line tangential to the circular path. It moves along the direction it has been moving at the instant being thrown up. So the direction of motion changed at every point when the coin was moving along the circular path. Thus, the direction of velocity of an object performing uniform circular motion is along the tangential direction to its position.